Hey, Mr. Clinton here. Today we're going to look at identifying characteristics of a function. So let's go ahead and take our notes out and we'll get going. Now, any time during the video, if you feel like you're falling behind, remember pause the video and get your notes caught back up. And if you didn't quite understand something, rewind the video and listen to it again. Sometimes it takes a couple times through to understand the concept. Okay, so what we're going to do is first, this is in our e-text, and that's chapter 1.2. So let's go ahead and go to our problem and get going. When identifying the characteristics of a graph, we are simply looking for the domain, the range, intervals of where the graph is increasing, intervals where the graph is decreasing, intervals where the graph is constant, and any local maximum or minimum points. So let's go ahead and begin on this problem. So quickly sketch the graph and make sure you get the key points. And we'll start with the domain. Now, previously we've covered the domain, so I'll quickly go over it. The domain, we're going to look for the farthest or the smallest x value that exists on the graph, and that appears to be negative infinity. And the graph looks continuous, meaning there's no holes in it. It goes all the way to positive 5 and stops. So our domain ends at 5. The range, I'm looking for the smallest y value on the graph, and it appears to be here. We're just going to estimate it and say it's at -1. It's close, a little before, but we'll just say -1, approximation. And the largest y value, if I continue up, the highest point on the graph here is at 5. And both those points are included on the graph, so I use brackets. Okay, let's talk about increasing, decreasing. Now, when we say increasing, that's where the graph is moving up. So I'm looking at my y's, and where are my y's increasing? Decreasing is where the values are getting smaller, and constants where they remain the same. So the way I approach this is I go over and start from the left side, and I see what the graph's doing. Now it appears my graph is coming down, so it's decreasing. So you can see it's coming down and appears to stop right here. So I can say on my interval, now I'm looking at the y's to see what the graph's doing, but my intervals will be reflected using x values. So when x is negative infinity, my graph is decreasing, and it goes all the way to where x is, it looks to be -3. So I do that on my number line. It just helps me, and I put a little arrow down and saying, okay, I'm decreasing from negative infinity to -3. Now, once I hit 3, I change direction. Okay, so from 3 all the way up to this point, which appears to be at +1, that interval, the graph, the y values are heading up, so I can say I'm increasing over that interval. And then once I hit 1, it looks like I'm decreasing again. So down here, I'm just kind of outlining what I'm going to do, and it's going to help me write my interval notation. And it looks like I'm stopping, it's just before 3, but we're going to estimate it and say it's at 3. And then lastly, it looks like it goes flat until 5. So I'm going to do that. Okay. All right, so I've kind of outlined my intervals of increasing and decreasing, so I'm going to go ahead and write it. I'm going to go ahead and start over here, and it looks like I'm decreasing. And we're starting from negative infinity. Remember, with negative infinities, we use parentheses. And it continues all the way to 4. Sorry, not 4, -3. I looked at the wrong value. -3. And I'm going to use a parenthesis because that point right on -3 is neither, where it turns direction, is neither increasing or decreasing. It's actually flat right there. And we're going to talk about that a little later. So all the points up to -3 are decreasing, and that's why I'm using a parenthesis. From there, it looks like we head up. So we're increasing. Again, a parenthesis because we're flat on -3, but just past it, we're increasing. And it looks like it goes to all the way to +1. So I'm going to put a +1 and a parenthesis because, again, at +1, I'm right here. And at that very point, it's flat. It's neither increasing or decreasing, so we can't include it in our set. And then it looks like I'm decreasing again. So I'm going to put my union sign, and I'm decreasing from 1 to +3. Okay, so at +3, it looks like I'm flat again. And this, you can see it's flat from 3 to 5. And that's where the graph is constant. It means the y is constantly the same number. And this time I get to use brackets because at 3, it is actually flat. It is constant there. So I'm going to go from 3, and it looks like it stops at 5. And since the point at 5 is solid, it's included. So I'm going to go ahead and use a bracket to close it off. And I do want to make note that if this point was open, then we have to use a parenthesis because 5 would not be included, but the points up 2 and 5. But we are solid, so it is included. Okay, lastly, we're going to look at the maximum and minimum points. Now, when we talk about maximum and minimum, we're talking about local. That means over in a certain area or interval, in a certain interval, we're looking for the maximum or the highest point. In a certain interval, we're looking for the minimum points. All right, we do have a difference between a global and a local. Global means the largest point, and I can see the highest point is going to be over here somewhere. That would be my global max, and it'd be up here at infinity. But we're looking for local max and mins. So I'm going to start here, and they occur when the graph changes direction. So I can see it comes up and changes direction. So I'm going to go ahead and identify this point where we said it was flat is a minimum. It's the smallest point. It's the smallest in this interval. So I can say I have a local minimum at the point -3. Now remember, this is not an interval. It's identified. It's a coordinate. So it's a point, an x, y. And we'll say -1. Okay. We have a maximum. So if we go up to the point up here, the tallest point in this interval, we can say its coordinate, remember it's a point again, is at 1, 5. Now please understand that these are points and these are intervals up here. You have to look at it in context of what we're doing. We're looking for a range where it's increasing, decreasing, or constant. Here we're looking for 2 points. And I also want to point out and make sure you add to your notes that you can have multiple local maximums and multiple local minimums. A maximum to me is always, I call it the top of the hill. So if you had multiple tops of hills, you can say those are all local maximums. And a minimum, I call it the valley in between. So if we have the multiple valleys or minimum points, we'd have to list those as well. Okay, go ahead and write down any questions you still have, and we'll answer them during class. Thank you for listening.